Hello. So I believe that this is on the concepts of how not necessarily that distance can be truly what you're out from, that displacement. If you could set them up as actual directional vectors to like tell somebody else, hey, step one, you went here, step two, you went there, step three, you got here. So what was the change between my step zero basically and my step three? So what you would start out with, I did this on an actual graphing program. You can do this on your own type of graphing paper of some sort of written scale. You could try to do one block for every kilometer, or 2 blocks, or one block for every 2 kilometers. Make that kind of easy. But the first step that you would end up having is you'd go from zero straight out 20 kilometers in whatever scale that you have east. So that'd be straight towards the right. The next path that you would then end up having is on layered right on top of that. You'd have going the 10 kilometers due north. Now you could get a result right here, but that's not the end of the trip. Then she does the 7.5 directly southeast, which is just another way of saying the size of that last leg of the walk is 7.5, but at 45 degrees down from the what would essentially be the positive x-axis of that type of a trip. So, like that picture implies, you'd go 7.5 down that direction on that way until you got to that endpoint. Now, to figure out the displacement, what you can end up doing with that is you can do what is essentially vector addition of tail to tip, where the tail of the next one meets up with the tip of the last one. Putting those all together, the total displacement is the final image that I have, which is from the very tail of the last to the very tip of the first. To do the actual mathematically, I put the equations on it, where if you knew the x and y spot of that point, you could do that. Or what you basically do is you put your ruler from the 0 point where it all started at down in the bottom left. The other point where you'd put your ruler is the very tip of the last displacement vector that you had. I colored it in yellow. You'd put your rulers there, measure it. It'd probably come out to some roundabout thing. Then you'd have to convert it back using your units. So let's say I had to create this graph and I was doing it on a 2 kilometers for every 1 block. So this would have been like 10 blocks or something. So technically this would have been like 12.55 or whatever that is divided by 2. So I would then be like, okay, well, if mine's 2 kilometers for every 1 block and I have about 12 something blocks, I have to double my number, get what the approximate R would be. And then theta, either if you actually had a protractor on you, you could measure the angle from the 0 spot upward. You can do that of measuring with a protractor, or you could also do a ruler and figure out like some way to drop down a straight line to figure out how far over that it went, and then also some sort of way to maybe get like a straight line measurement back over to your y-axis to figure out how far up it was, and then actually apply that one and get probably a little bit closer to the 10.5 degrees that the final answer is. I hope this helped. You can message me on the tutoring site if there's anything that you need run through more in depth. Thank you. Have a good day.